The first thing is that you need to have components to be able to apply joints to them, but joints themselves are a different creature. I don't know how many of you have tried, those that are experienced Inventor and have tried using joints in Inventor. If you did and it seems just a little awkward or off, there is something really important about joints in Fusion and Fusion 360 to think of compared to constraints. When applying an assembly constraint, you are working from a position of the assumption that all degrees of freedom are available. So when you're in Inventor and you're actually starting to put constraints in, what you're doing is actually removing the degrees of freedom. So you apply a make constraint, which removes the freedom of the parts to move apart from each other. You then might add a flush constraint to align it to a side, and then another flush constraint to align it to another side, etc., etc., until you have removed all the degrees of freedom on the two parts, so that they're in position and they move exactly like you want. The way joints works, or the way the joints look at things, is that the assumption that you will be removing all the degrees of freedom at once, and then we'll come back and based on the type of joint you select, you will be telling it what degrees of freedom you would like to release. So it seems a bit subtle, but in application you'll find that you need to apply fewer of these controls and they are just smarter. Another thing that is different is the ability to select the geometry. Make your options or your choices known, then define what type of joint will be placed. So I'll show you a couple of examples. We'll go through the one exercise, but I also want to show you a couple of quick examples too. Then there is the case of something called as built joints. I mentioned before that if you have a design, say like the jewelry box that I referred to earlier, you've got the lid, you have the body, and then later down the line you want to show people how the lid pivots. You can of course convert these bodies to components, so at any time you can go back into Fusion, and if initially it was just being a static image, but now you want to actually do some animation with it or show people how it works, you can go back and you can create the various bodies into components, but you've already drawn it in the correct position. So what you can do, you can apply an as-built joint to take advantage of that current position that the lid and the box are in. You can also set motion limits, use contact sets. All the things that were considered a little more advanced in, say, tools like Inventor are already in Fusion 360 as well. So let me just mock up a quick example of joints and we'll then come back to the more conventional example. So what I'm going to do, back into Fusion here and new design. So what I'm going to do, first of all, I'm just going to create a simple plate on here. I'm not going to be bothered about too much size of it. I'm going to extrude it 10 millimeters, something like that. I'm not being too bothered about that. Now, what didn't I do? I didn't create a component at first, yeah, which is a little bit annoying, but what I will do, I'll do it proper like I should do. So what I'm going to do is just click on that and just delete it, delete, and delete that. So delete my timeline, right click, new component, just call this plate 1. Okay, so now when I start, draw my rectangle, there, extrude, up, say around about 10 millimeters. Yeah, they just want it to be a new body. Actually, I could have gone new component when I was actually in there, so yeah, I just did something. Now what I want to do now is make a second component that I'm going to attach to this. So I'm just going to create a new sketch. So what I'm going to do is try it another way. So sketch, 2-point rectangle. This time, let's do a rectangle. I'm just going to put on there. Extrude that upwards. But rather than join, if I go new component, make that 10 millimeters. There. Okay. So I've got now. I didn't actually put that as new component, did I? So let's do that. change from new body to, doesn't give me an option there to create it as a new component. Let's just cancel that. Let's open it up. Have I got, so I should have two bodies. Got one body, which is that one. Component 2, it's put it underneath that one. Yeah, because I've got plate 1, and because I didn't create it there, it's put it in there. So maybe I can move this and move the level of it. There we go. So you can, as you can see there, I created that component, but I had it at the wrong level. I'd actually created it underneath this plate 1. So all I had to do was click and drag it to my top level, and it's now created it as a separate component, which I can, there you go. I can highlight there as point 2. Now, what you got to think, how would you fix these components in position? So say I wanted to, if I now just highlight and activate the top level again, so we've got both of them. So I've got two plates, plate 1, plate 2. Thinking about Inventor, you know, maybe I wanted to add mate or flush these faces, or mate these two faces, then I have to align or flush these two faces to get them lined up. What I can actually do in Fusion is in Assemble up at the top, I can actually do joint. Yep. Now, one of the things I need to do prior to using the joint is actually ground one of these components. Yeah, make sure that it's fixed in space. Otherwise, it doesn't know in 3 dimensions what's being located to what. My first plate, if I right-click on it, I've got a ground option. Click on the ground, you notice I get the little pin next to it. That means now that that is now fixed in space and I can't move it. This one I can pull around, this one I can't. So I've now moved that, moved it around. If I go to the joint tool, I'll just capture that position where this is at the minute. Now what you will notice as I hover over each one of these faces, I get different selection parts and different sort of options here. So if I wanted to have like a flush face, I could actually pick this point here or this side underneath here. So if I said I wanted that to be with that point there, automatically comes as a rigid fix. I've got my manipulators, so at this moment in time I can spin it, I can move it, as well as having the options to do this here. I can move this around. Yeah, I can even lift it off, so I can actually, you know, join something, but with a gap between it. I can do all that here. I could change the type, so if I went revolute, yeah, it asked me what axis do I want to actually revolve that around, but I'll just go in at the moment. I'm going to do a rigid, and I'll just move it out and spin it around to there. Okay, and that's actually now joined together in that position. Yeah, it's now fixed. So how, you know, if you compare it to Inventor and using constraints, the amount of time. Ground again, Sam, I'll explain ground again. If I remove, let's unground this. So what happens now, yeah, I'm going to actually remove these joints as well. So let me just delete that joint. So at the minute now, I've got these objects. Let me just remove ground, unground that, continue. Right. So I've now got these two plates that I've drawn in a 3-dimensional world, but at the minute they can both move relative to one another or independently. Nothing is actually fixed. So if I was to start to try to assemble these two components together, which one would move to which component? You know, would one move to the other, or would one stay still and the other one move to it, or would they both move towards each other? We've got no sort of reference to work to. So what grounding does, it actually fixes one of our components in its location and says like, that's where it needs to be, that's where it's going to be fixed. So what I can do now is with this plate here, if I ground that, so I've right clicked on it and pressed ground and capture position, that's just where it is. Now, you know, if I try and select it and move it, it doesn't move. This one does still, but that one doesn't. So I know now once I start applying joints, this one is going to move to this one here. So I've got this physically fixed in this location. Again, assembly, join. Yeah, I'm just going to capture this position here. Hovering over this edge there, if I was to click that one, which was like the rotate part there, and that edge part there, yep, these are both located together on the midpoint. I can spin that round. I could change it to a revolute joint. As you can see, I'd have to put some remove some degrees of freedom in there. And I just move that to 0. There. And then just move this out a little bit and across a little bit. Yeah, I can very quickly put in some dimensions there to locate something solid. And then press OK. Now, one of the things we can do, this is if I'm building something, I'm not so sure exactly if it's going to work or whether the concept that I'm designing is going to work. We can actually do something called what's it called now? As-built joints. Sorry, yeah, as-built joints. Just to show this, I'm just going to quickly create a new component. So sketch, assembly. Let's try this. Assembly, new component on this top surface here. Component 3, empty component. C parent wants to be top level. Yep. Dum dum dum. And circle into diameter on that top face. So if I was to position a circle, so something like this, start sketching, extrude that upwards. You see it's added another component in here. And then just to make this a bit clearer, what I'm going to do here is just draw another, say what, let's do sketch, rectangle, zoom in. I'm just going to overlap that a little bit. If I then press pull that bit and just move that down a little bit. Okay. So what I've actually done now is I've just created another component on here, this that I've got in position that I think might work. The only thing is, what I want to do is test it. So I've not put a hole in anything yet. This is just prototyping. What I'm going to do is now create assembly, as-built joint, the components. So select the one that's going to move first, then that one. Position is that center there, and it's picked up a revolute joint there. Okay, so now what I've actually done is I've put an inbuilt joint. It recognized that it wanted to be a revolute, and I can actually should be able to pull this round. Which one's it picked up on? It's picked up on that one. Let's suppress that joint in a minute. Let's just pick up on this one. Suppress that. So this has now picked this joint, and what I can do is I can actually drive that joint. I can actually spin it round, and I can make sure here, whilst I'm doing this, that before I actually make any more modifications and changes to my plates, I'll start drilling holes in. I can see whether it works like I want it to work. So that's an as-built joint.